Hi, I'm Cheryl Leach. The exercise that we're going to look at in this video is an optimization problem. Let's go ahead and look at the particular problem. It says we want to find the length and the width of a rectangle whose area is 49 square feet, who has a minimum perimeter. All right, well, let's see, this is a word problem. And oftentimes in a word problem, the best way to begin is by drawing a picture. So let's see what we have. We're looking at a rectangle. And it's also helpful to assign some variables. So I'm going to go ahead and let the length be x and the width be y. Well, what other information was I given in my problem? I know that the area is 49 square feet. And to find the area of a rectangle, we multiply the length and the width. So that tells me that x times y equals 49. Well, that's basically what I'm told in the problem, but what is it that I'm supposed to find? Well, I'm supposed to find the length and the width, but under what conditions? I'm looking for that length and the width when the perimeter is a minimum. Those two words are very important because the perimeter gives me another geometric piece to look at, and the minimum tells me what am I supposed to do with that? Well, I want to optimize it. In other words, find the minimum or the maximum, and in this case, the minimum. So I want to begin with an equation for perimeter. So that's what I call my primary equation. And the perimeter is 2x plus 2y, because it's the distance around the edge of my rectangle. Well, if I look at this equation, I notice that there are two variables in it, the x and the y, that act as independent variables. I would really like to write this as one variable. So, how can I accomplish this? Well, let's go ahead and look at my secondary equation. I noticed that I was given that x times y is 49. I'm able to solve that equation for one of the variables. And it doesn't really matter which one. Choose the easier method, but in this case, it's about the same. So I'm going to solve for y and write y equals 49 over x. I'm then going to take this information and plug it into my primary equation. So my perimeter is 2x plus 2 times 49 over x. Great, now I have my primary equation and it's written in terms of a single variable. I think I'm going to do a little bit of algebra on this to clean it up. So the perimeter is 2x plus 98 over x. And you can even write 98 over x as 98 times x to the minus 1 power. So I have 2x plus 98 x to the minus 1 power. Now remember, I'm trying to minimize the perimeter, which means I'm looking for a relative minimum. So that means I need to find critical numbers. That means I need to take the derivative. But before I do that, let's take a step back for a minute and talk about the possible input values for x. Notice in the algebra equation, I'm dividing by x, which means I don't want x to ever equal 0. The other thing I want to look at is a geometry perspective. Because I have a rectangle, it's not going to make sense for that x value to be a negative number. So I know that I want x to be strictly greater than 0. All right, I think it's time now to find those critical numbers. dp dx is going to equal 2 minus 98 x to the minus 2nd power. Critical numbers occur when that derivative is either equal to 0 or undefined. It can be a little difficult to determine when that happens when my derivative is written in that form. So what I'd like to do is write this as a single fraction. So my first step is to change that x to the minus 2 power into 1 over x squared. Then I'm going to combine these two terms together so that I have 2x squared minus 98 all over x squared. So now the two questions I have to ask, when is dp dx equal to 0? And when is dp dx undefined, are a little easier. So let's take a look at the first piece. When is it equal to 0? I have a fraction. A fraction is equal to 0 when the numerator is 0 and the denominator is not simultaneously 0. So let's see when that happens. 2x squared minus 98 equals 0. So 2x squared equals 98. X squared equals 49. That leaves me with plus or minus 7. Again, I'm not going to need to worry about that negative 7 because it doesn't make any sense for a rectangle to have a side that's negative 7 feet. So 7 is the one I want to focus on. Right? Also notice that that does not make my denominator equal to 0. Okay? The next piece of the puzzle, though, is when is the derivative undefined? Again, I have a fraction. When is a fraction undefined? It's undefined when the denominator is equal to 0. So that means that x squared will equal 0, or x is equal to 0. While this is a critical number, it's not one that I'm interested in because, again, I know my rectangle is not going to have a length of 0. So really the piece that I want to focus on is this number 7. So let's go ahead and fill in our table to see what's happening at 7. So we're going to break down our interval. We're going to go from 0 to 7, and then from 7 to infinity. Well, let's take a test value. On the interval from 0 to 7, choose anything you like. Let's try an x equal 1. Now we're looking for the sign of the first derivative. So here's a nice expression of the first derivative. What happens when x equals 1? Well, I'm going to have 2 minus 98, which is a negative number, divided by 1 squared, which is positive. A negative divided by a positive, that's negative, which tells me that my perimeter equation is decreasing. Let's do the same thing for my interval from 7 to infinity. Pick any number you like on that interval. Let's try 10. When I plug 10 into my derivative, I'll have 100 times 2, or 200 minus 98, a positive number. X squared is always positive. Positive over a positive is positive, which means that my function is increasing. So what's happening here? Well, my function begins decreasing, and then it turns and begins increasing, and it increases forevermore. Well, what does that tell me? Well, it tells me that there's a relative minimum right at that changing spot, right at 7. But because of the way the graph is shaped, not only is that a relative minimum, it's the absolute minimum as well, which is what we're looking for. So x equals 7 feet is going to be the dimension that will give me a minimum perimeter. Now be careful, it asks for the length and the width. I've only given you the length. So how do I find the width? Okay, well, back to our secondary equation. I know that the width, which I've written as a y, is 49 divided by x. So y is 49 divided by 7, or 7 feet. And so our particular rectangle with a minimum perimeter is going to be the square that is 7 by 7. Thanks. I hope this helped.